Space is vast and full of mystery. It is hard to imagine how big it really is. When we look up at the night sky, we see stars, planets, and galaxies. These objects are very far away. They are so far away that we measure their distance in light years. A light year is the distance light travels in 1 year. Space exploration helps us learn about the universe. We use telescopes to see distant objects. We send probes and rovers to other planets. We even send astronauts into space. All of these things help us learn more about the universe and our place in it. As we explore space, we are finding more and more amazing things. We are finding new planets and stars. We are learning about the history of the universe. We are even starting to search for life beyond Earth. The universe is full of wonder and amazement. The more we explore it, the more we realize how much we don't know. But that's what makes space exploration so exciting. It is a journey of discovery that will never end. Stars are born in giant clouds of gas and dust. These clouds are called nebulae. Nebulae are very cold and dark. Gravity slowly pulls the gas and dust together. As the gas and dust get closer, they heat up. Eventually, the cloud gets hot enough to glow. This glowing cloud is called a protostar. The protostar continues to grow as it pulls in more gas and dust. Eventually, the protostar gets so hot and dense that nuclear fusion begins. Nuclear fusion is the process of combining atoms to create energy. This energy is what makes stars shine. The birth of a star is a long and complex process. It takes millions of years for a star to form. But once a star is born, it can live for billions of years. The life cycle of a star is determined by its mass. Massive stars live shorter, more dramatic lives than smaller stars. All stars, however, follow a similar path of birth, life, and death. Stars begin their lives as giant balls of hydrogen gas. The intense pressure and heat at the core of a star fuse hydrogen atoms together, creating helium and releasing tremendous amounts of energy. This process is what makes stars shine. As a star ages, it gradually burns through its hydrogen fuel. Once most of the hydrogen is gone, the star begins to fuse helium into heavier elements, like carbon and oxygen. This process releases even more energy, causing the star to expand and cool. The star becomes a red giant or supergiant, depending on its initial mass. Eventually, the star will run out of fuel to burn. What happens next depends on its mass. Smaller stars, like our Sun, will shed their outer layers, forming a planetary nebula. The core of the star will remain as a white dwarf, a dense hot object that slowly cools over billions of years. Massive stars, on the other hand, meet a more violent end. When they run out of fuel, they collapse in on themselves, creating a supernova explosion. This explosion is so bright that it can outshine an entire galaxy for a short time. The core of the star may survive the explosion, becoming a neutron star or a black hole. Galaxies are vast collections of stars, gas, dust, and dark matter, held together by gravity. They come in a variety of shapes and sizes, from spiral galaxies like our own Milky Way to elliptical galaxies and irregular galaxies. Spiral galaxies are characterized by their spiral arms, which are regions of active star formation. Our solar system is located in one of the spiral arms of the Milky Way. Elliptical galaxies are smoother and more rounded than spiral galaxies. They contain older stars and less gas and dust. Irregular galaxies have no defined shape. They often result from collisions or interactions between other galaxies. These galactic interactions can trigger intense bursts of star formation. Galaxies are not randomly scattered throughout the universe. They are often found in groups or clusters, held together by their mutual gravity. The Milky Way, for example, is part of the local group, a collection of about 50 nearby galaxies. Section 5. Searching for life beyond Earth. The search for life beyond Earth is one of the most profound quests in science. While we have yet to find definitive evidence of extraterrestrial life, the vastness of the universe suggests that we are not alone. Scientists are looking for signs of life in many different ways. One way is to search for planets that orbit other stars, called exoplanets. These planets must be in the habitable zone of their star, where temperatures are just right for liquid water to exist on the surface. Another way to search for life is to listen for radio signals from other civilizations. This is the goal of the SETI Institute, which uses radio telescopes to scan the skies for artificial signals. The discovery of extraterrestrial life would be one of the most profound events in human history. It would forever change our understanding of our place in the universe and raise profound questions about the nature of life itself. Section 6. Black holes. Gravity's ultimate triumph. Black holes are among the most mysterious and fascinating objects in the universe. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. Black holes form when massive stars collapse at the end of their lives. As the star collapses, its gravity becomes so intense that it warps the fabric of space-time. The star's core is compressed into an infinitely small point called a singularity. The singularity is surrounded by an event horizon, which is the point of no return. Anything that crosses the event horizon is trapped inside the black hole forever. Black holes cannot be seen directly because they do not emit light. However, their presence can be inferred from their effects on surrounding matter. For example, gas and dust spiraling into a black hole form an accretion disk, which heats up and emits X-rays. Section 7. Shooting stars and planetary atmospheres. Shooting stars are not actually stars at all. They are small pieces of space debris, called meteoroids, that enter Earth's atmosphere. As a meteoroid travels through the atmosphere, it heats up due to friction with air molecules. This heat causes the meteoroid to glow brightly, creating a streak of light across the sky. Planetary atmospheres are layers of gas that surround planets. Earth's atmosphere protects us from harmful radiation from the sun and helps to regulate our planet's temperature. Other planets in our solar system have very different atmospheres. For example, Venus has a very thick atmosphere, made mostly of carbon dioxide, which traps heat and makes the planet extremely hot. Section 8. The importance of space exploration. Space exploration is important for many reasons. It helps us understand our place in the universe, inspires future generations, and drives technological innovation. Studying space helps us learn about the history of the universe and its mechanisms. It also helps us understand our own planet and its place in the cosmos. Space exploration inspires young people to pursue careers in science, technology, engineering, and math, often referred to as STEM. Space exploration drives technological innovation. Many technologies that were originally developed for space exploration have found applications here on Earth, such as GPS, scratch-resistant lenses, and memory foam. Section 9. Conclusion. Our place in the cosmos. The universe is vast and full of wonder. As we continue to explore it, we are constantly making new discoveries that challenge our understanding of the cosmos. From the birth and death of stars to the search for life beyond Earth. Space exploration is a journey of discovery. that will never end. By studying space, we gain a better understanding of our place in the universe and the interconnectedness of all things. Space exploration is an investment in our future, inspiring innovation, and ensuring that humanity continues to push the boundaries of knowledge and exploration.